I'm going to show you how you can use Arize to monitor your machine learning models and get insights into production machine learning issues. Alright, to start out, we're here on the Arize homepage. This page gives you an overview of your activity. You can see your models over here on the left, your monitors here in the middle, and dashboards on the right. To start out, let's dive into this particular model. This is a binary classification model, and it's making predictions on individual credit card transactions to determine whether those transactions are legitimate or fraudulent. Up here at the top, we've got our false negative rate over time. This is measured on production data. We care about false negative rate because this is a fraud detection problem, but you can configure this chart with more than 100 different metrics, and if you don't find a metric that suits your needs, you can create your own custom metric. Below our performance chart, we have our model health card. This is showing us our model's features, predictions, and what we call actuals, which is our name for ground truth. We've also got %empty and PSI. These are data quality and drift metrics, just so that you can know that your data is healthy. And up in the top right, we have our monitors. There are 3 kinds of monitors: drift, data quality, and performance. Some of these monitors are created for you by the Arize platform. Some of them I've created myself in order to customize them to my particular needs. And here you can see I've got one performance monitor that has been triggered. So let's dive into the monitors tab to see what's going on. In this tab, I can filter so that I'm only seeing custom monitors that I created. I can also filter on performance monitors that are currently triggered. And what I'm left with is this false negative rate monitor that I created a few days ago. As you can see, this monitor is in a triggered state. So let's dive in and see what's going on. On this page, you can see that my false negative rate has recently risen above the acceptable threshold, which is that yellow dotted line you see. And I was already alerted of this fact even before I entered into the platform because I've got my Slack notifications configured. One of the real strengths of our platform is that we're not only going to alert you when something goes wrong, we're also going to help you figure out why something is going wrong. So let's do that. Let's troubleshoot our model performance. That brings us over to the performance tracing tab. And if you've heard of the notion of tracing in the context of distributed systems, this is a very similar notion. The idea here is that we are going to help you get to the bottom of your issues in production so that you can understand the root cause of the issue and fix it as quickly as possible. So once again, we've got our false negative rate over time here at the top. I'm going to zoom out a bit. And I want to dive into this time window right here where the false negative rate is at its peak. Down here in the bottom left, you can see the worst performing of what we call slices. A slice being a particular value for a particular feature that we have identified as being problematic. So right here you can see we're dealing with a slice where the merchant ID feature is equal to scameds, which is a particular merchant. I'm going to dive into this slice. And what you're seeing here is the distribution in production during this time window for this particular feature. And you can see that this particular bar of the histogram, which refers to the scameds slice, is in red. And it's in red because it has a really high false negative rate. You can see that our false negative rate on transactions coming from this particular merchant is above 93%. That's pretty bad. That means that we are letting through a lot of cases of fraud. A lot of these fraud cases are going undetected. So we want to start trying to get to the bottom of this issue. And to do that, I'm going to add a training data set for comparison. Now when I scroll back to my histogram, I've actually got 2 histograms. I've got 2 distributions side by side, my training and my production distributions, and you can see visually that those distributions are quite different. And really, the reason they're different is because our production distribution has about 70% of its data coming from this particular merchant, and we have no training data from that merchant. Now I'm just drilling down deeper into this feature. What you see at the top here is a graph that measures the amount of drift for this particular feature over time. And you can see that the drift is indeed increasing over time. If I drill down into one of these blue points where the drift is relatively low, down here you can see side by side my training and production distributions. And indeed, these two distributions are quite similar. It's true that we are seeing some ScamEds data in the production distribution in blue over here on the right that we're not seeing in training, but by and large, these two distributions look pretty similar. If I come up here to this red plot where the drift is high, now you can see that my two distributions are very different. I'm seeing a lot of ScamEds data in production that I don't see in training. All right, so at this point, we have uncovered a feature drift issue. I want to approach this problem now from a different perspective, from the perspective of explainability. I'm going to dive into our explainability tab. And what I'm going to do here at the top is I'm going to create two data sets. Both of them are going to contain production data. Dataset A is going to contain all of my transactions that did not come from the ScamEds merchant. And dataset B is going to contain all of my ScamEds transactions. What this chart is showing you is the importance of each individual feature to the predictions in each of these groups that I've configured. And by and large, you can see that the blue and purple bars are mostly the same length. That just means that most of these features have the same importance regardless of whether or not we're predicting on ScamEds data. There is one very notable exception though. If you look right here at this feature merchant risk score, you can see that this feature is quite important when it comes to making predictions on ScamEds data. The purple bar is pretty long, but it's not very important on making predictions on non-ScamEds data. The blue bar is very short. So there's this big disparity for this particular feature, and I'm going to drill down into this feature so that we can investigate what's going on. I'm going to quickly remove one of my filters so that I'm only looking at ScamEds transactions. And if I scroll down to the bottom, this chart, %empty over time, should be pretty illuminating. You can see here that between 11 and 22% of my transactions coming from ScamEds are missing the merchant risk score feature. That feature is empty. And given what we know about how important this feature is, this could be a potentially alarming fact. So here at this point, we've uncovered a data quality issue. All right. So at this point, we've uncovered both a feature drift issue and a data quality issue. Now I want to surface these insights to the rest of my team. And to do that, I'm going to create an Arize dashboard. Creating a dashboard is very simple. All I do is go here, I create my dashboard. I can actually use one of these templates. By using a template, my dashboard contains several widgets automatically. So for example, here I've got my feature distribution for the feature merchant ID. Here I've got false negative rate over time. Here I've got my global false negative rate. I can also add my own custom widget, which I'm going to show you now. And that's all it took. So now I've got this custom widget, which is showing me the merchant risk score distribution for both ScamEds and non-ScamEds data. All I need to do is copy the URL and I can share this dashboard with my colleagues so that they can also understand the insights that I've uncovered with this platform. All right, cool. So now I want to switch gears a little bit. I've showed you a structured use case. Now I want to dive into an unstructured use case. I'm going to dive here into this computer vision model. This particular model is trained on an image classification task, where we're trying to predict the action of people in photographs. For example, is the person in this photograph walking or running or eating or sitting down? In order to get insights into this kind of unstructured use case, we're going to use what are called embeddings. An embedding is just a vector that represents a piece of data, in this case an image. And if we have good embeddings, that means that they contain some meaningful information about that data. I'm going to make this idea concrete just by jumping into our embedding insights page. Up here at the top, you can see the drift of our production embeddings relative to our training embeddings over time. I'm going to dive into this period of time where our production embeddings have drifted from our training embeddings. Now I'm going to go down and generate the UMAP. UMAP is a dimensionality reduction technique. What it's going to do is it's going to take those high-dimensional embeddings that were ingested into the platform, and it's going to reduce them down to 3 dimensions so that I can visualize the data. What you can see here is the UMAP plot, and in blue I've got my training data points. In white I've got my production data points. And I'm actually able to interact with this plot. I'm able to move it around. I can zoom in and out in order to get a better feel for my data. Now I'm going to use this plot in order to actually explore and inspect some of my data. So what I've done is I've applied a filter so that we're only looking at training data. I'm going to use this lasso to zoom in on these points right here. This gives us a little bit of a feel for the data, and you can see that in this particular cluster, it looks like all of these examples are images of people sleeping. So that should be pretty reassuring, actually. That just means that our algorithms are doing a good job placing similar images close together. I'm going to backtrack for a minute, and I'm going to reintroduce my production data. Not only can you interact with the plot via the lasso, but Arize is also going to point out these clusters over here. These are going to be, at the top, the most problematic clusters. So let's take a look at this cluster right here. The reason this cluster is problematic is because it consists almost entirely of production data. And that's potentially a problem because in this region of our data, we have our model making predictions on data points, the likes of which it has never seen during training. If we actually inspect some of these data points over here on the right, you can see that they are in fact different from the training images I showed you a moment ago. In particular, they all have this noise added to them. And that is causing our model to actually misclassify some of these examples. You can see this is an example of an image that's being misclassified. The correct class is calling, but our classifier thinks that the person is laughing. Here's another misclassified image. This is a picture of someone drinking, but our classifier thinks that the person is laughing. And we can actually confirm that this cluster contains a lot of incorrect examples by coloring our data set. Now, instead of coloring our data set by production versus training, the data points are colored by whether or not the prediction was correct. So blue data points mean the prediction was correct, and red data points means the prediction was incorrect. And in this cluster that I just showed you a moment ago, it's lit up right here, you can see we have a lot of red data points. That just means that we made a lot of mistakes. And so at this point, we might conclude that we need to export this production data, label it, and retrain our classifier in order to improve the performance of our classifier on these kinds of examples. I've shown you Arize's capabilities for both structured and unstructured use cases. I highly encourage you to go to arize.com, create a free account, and try the platform for yourself.